Alright, welcome back. We're going to look at number 20, just number 20 in this video, which is the one about logistic growth. Alright, logistic growth. So here was that complicated type of problem. Remember where we said C is our population cap, but here A and B mean nothing. On Tuesday, we'll talk about exponential growth and exponential decay, where A and B actually do have a meaning from our story problem. But here, because we are talking about logistic growth, A and B mean nothing. We have to do a little bit more work to find A and B than just pulling it out of the story. But C we can pull right out of the story. So let's read this real quick. The population of field mice is growing according to a logistic model of y equals c divided by the quantity of 1 plus a times b to the power of x. Initially, there are 50 mice. Initially, always means 0 and then our value of mice. So here we have 1.050. 2 weeks later, there are 400 mice. So here we could write 14 or 2. I like 2 just because it's an easier number to deal with. And then 400 mice. Due to limited resources, the capacity for the area is approximately 12,000 mice. So that would be our cap there of 12,000 mice. Find the equation to model this population. So we might be real tempted, just like in exponential growth, to plug this 50 in for the A. We cannot do that here. We have to go a pretty long way of finding our equation, all right? But we can use this cap. So our cap is what C is, so we can plug that in first to say y equals 12,000 divided by 1 plus a to the times b to the power of x. We always then use our 0 number next, and I will always give you an initial value or a starting value. So what we just need to do is plug in our value. So y is 50, and then we want to plug in our x. We still don't know our a or b, so those both stay as letters, and then our 0. Remember, when we raise anything to the power of 0, we get a 1, so our b term kind of just disappears. So here we're just kind of left with 12,000 on top and 1 plus a on the bottom. So when we try to solve for this, let me rewrite this so it's not so confusing. We want to get that stuff out of the denominator. So first we'll multiply both sides by our denominator. Alright, so then we'll get 50 times 1 plus a equals 12,000, and then we can divide both sides by 50. So we get 1 plus a equals trying to do this in my head right now. We get 250. So then we would need to subtract 1 on both sides. So we do get, and I'm sorry for the mess, a equals 249. Alright, so we have c equals 12,000. And now we have that a is equal to 249. So we can still use our same equation. And now we have to do a little bit more work to find what b is equal to. Because as we notice, we still have y, b, and x as unknowns. And that's when we use our second point, which we said was 2 weeks and 400 mice. So just like we did in the other one, we're going to plug our information in. So our y is 400. We get 12,000 on the top and 1 plus 249. And here we can do b to the power of 2. So now we have to find, just like the other side, we have to do that little bit of math to find what our value of b will be. Alright, so we need to move our denominator over to the other side. Alright, and we're going to multiply both sides by the denominator. So we get 12,000 equals 400 times 1 plus 249b squared. And then we divide both sides by 400. So now on the left, we have a nice clean number, at least for now, of 12,000 divided by 400. Which is 30. Alright, so we can subtract 1. So we have 29 equals 249b squared. Divide both sides by 249. So I'm going to, sorry for this, jump all the way back up here. Nah, I'll be clean and move on to the next one. So we get b squared equals, alright, whatever 29 divided by 249 is. So b squared is equal to, and for these problems, we can always round to 3 decimal places unless I tell you to do so. It should be 116, and then we have to find the square root of that, right, to get rid of that power. If we had something besides the square, we could also write this as we're taking 1 over 2. So that way you can always use this method if we have a power of 3 or something like that. We take the power of, you take the power and put it on the bottom of a fraction with 1 on top. So if we plug that into our calculator, alright, we get b is equal to 0.341. So our final equation now is going to be 12,000 on the top. Alright, that's our capacity. And then we found that A was equal to 249. And we just said that our B was 0.341. Alright. So that is our final equation, and I'll see you in the next video for the last page, which is all about radians and trig.